Lesson 4 is isometric drawings. So isometric drawings use what's called isometric dot paper, as you can see on this picture. Also, that drawing looks funky. I'm pretty sure the line's supposed to go right there. Ignore that other one. I don't think it looks like that on yours. Okay, so what we do is we compare dots to sizes. You don't actually have to do any measuring on this one. So the following is an isometric drawing done on isometric dot paper. The height of the box is 15 centimeters. So that means that this right here is 15 centimeters. So what we're going to do is we're going to compare by counting the space between the dots. So 1, 2, 3, 4, 5. So our scale statement is 5 dots represents 15 centimeters. Now we can use this to find the length and the width. So let's do the length first. Let's make this the length. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8 dots. So we're going to start with our scale statement. 5 dots is 15 centimeters. We have 8 dots. We are looking for the centimeters. Is this a problem I know how to solve? Yes, it is. What's it called? Proportional reasoning. How do I solve for it? Cross multiply and divide. So we have 8 times 15 divided by 5. And we should be left with 24 centimeters. And the dots will cancel. So we have 24 centimeters is the length. Now let's do the width. So 1, 2, 3, 4 dots for the width. So we go 5 dots is 15 centimeters. We have 4 dots. How many centimeters is that? So cross multiply and divide. And you should get 12 centimeters. So that is how you use isometric dot paper. Okay, example 2. You're drawing an isometric drawing for a box that has the dimensions of 100 centimeters by 60 centimeters and a height of 40 centimeters. Draw, the scale is 1 to 20. Draw on isometric dots. So first off, we're just going to measure the space between the dots. So if you measure this space, you should get it that's a half a centimeter on yours. So we actually kind of have to do 2 conversions. So first we're going to do the scale factor. So 1 over 20. Let's do the 100 first. So it's actually 100 centimeters. X goes on the top. So if I cross multiply and divide, I get 5 centimeters. You know what? Let's just, we don't even need to say it's half a centimeter. Let's just say that 1 dot is going to represent 1 centimeter. And we can just write that on there, and then that's our scale statement now on the picture. That'll be easier. That's what we're going to do. Okay, so 1 over, we're just going to do that for all of them. So 1 over 20 is x over 60. So you should get 3 centimeters. And then our height is 1 over 20 is x over 40. And we should get 2 centimeters. So this way we can say that each, we just have to draw the spaces for this, and as long as you write this on your scale, people will be able to follow along with that. Okay, when we're drawing, you have to start with the height. It's the only way that it really works. So our height is 40 centimeters. So that's 2. So we're going to start, it doesn't matter where you start, maybe somewhere over here, and draw it to go 2 lines. So start there to make it go up 2 lines. So there's our height. Now let's do our width going backwards because I have more space for that. So 1, 2, 3, 4, 5. And we're going to do it on the top and the bottom. And then we could draw that height in again. And it's also 2. It shouldn't change. And now we're going to do our width, which is 60 centimeters, which is 3. So 1, 2, 3. Oops. 1, 2, 3. And then our height doesn't change, it's 2. And now we can fill in the rest of the back, so it's 5 still. So 1, 2, 3, 4, 5. And then this should be 1, 2, 3. So there is our box drawn in proportion. This is nice because it gives us that angle to make it three-dimensional, and it looks like it stays in proportion. You should also be using a ruler, unlike what I just did. Alright, bye!